good afternoon, and good morning to everyone out there. Let us know if you cannot see the screen or hear the audio at any time during the presentation, but let's kick off. So my name is Putra, and today I'll be giving you through down. We'll start with just with a bit of a slideshow presentation of what's coming in this release, and I'll finish off just with a live demo of some of the new features that we'll have in this release. So this release is tailored towards basically improving people's workflows in ioGAS. So our strong focus is in improving the way that people can bring in data into ioGAS and how they can turn all this data that they can import into ioGAS and turn that into information that they can export out of the program. So some of the new headline features that will have in version 8 is the workflow recorder function, which basically allows people to record a sequence or a series of actions within the program and have that be repeatable across a different data set. And we have a new feature called data reload, which means that if you receive new assay data from the lab and it updates your original assay file, if you click on that reload button in ioGAS, you can keep on going and continue your work without having to reopen everything from scratch. And lastly, we have added a couple of new features in terms of improving our customers' workflow, strong improvements to the user interface. So we have added the undo and redo function. So people have been asking us for that feature for years now, and we finally added that function in. Basically makes the journey to interpret your data in ioGAS a bit more friendlier. And we've added a tool search function as well. So we know that over the past few years, ioGAS has gotten quite a bit big, and it might be hard to find certain functions and tools within the program. But the tool search function will allow you to do exactly just that. Just makes it easier for you to keep going and find certain things without interruption. Most of the other things here on the screen we will run through as we go through the demo, and we'll certainly touch on them in a lot of detail. So I'll start off just with talking a bit about the workflow recorder. So as I was saying before, the workflow recorder allows you to record a series of ioGAS operations. So from simple basic functions such as validating your data using the data doctor. So things like applying below detection limit replacement. So if you're dealing with the same type of assay data and you have a certain set of way that you would replace your below detection limit value, for example, you can record that functionality using the workflow recorder and the data doctor. So the workflow recorder records everything you do, and that includes when you create a plot, when you open a diagram, when you run things like PCA, and any of the analytics tools that we have in ioGAS. ioGAS records all of these in the workflow recorder. And that allows you to automate and sequence a bunch of things that you can run in order within ioGAS. And the recorder is a live recorder, right? So, and we will show you how that will work when we run through the live demo. So some of the key functionalities of workflow recorder include the ability to automatically play things from start to finish with no interruption. So that allows you to generate the end product, which can be a classification column, for example. So you can choose to run things from start to finish and output that classification column as a CSV file and have that run with minimal or no interruption from the user at all. And you can choose to run things through in steps. So you can choose to take it slow and just run through the steps as recorded in the workflow. And you can add sort of a manual step in between recorded steps, which means that you can add a step, for example, if you want to have a pause between opening a probability plot and opening an XY plot, for example, and have a step in between that say, please take a look at this probability plot before proceeding, because you want to select the right variables to open up in a scatter plot, for example. So adding that manual guiding step, and another good example would be open up this diagram and highlight features that are unique to this data set, for example. So that's what we call sort of that guided workflow. And the thing about workflow is that you can record it and you can save it as an XML file. And the recorded XML file can of course be shared with other people within your organization. And if you happen to be a geochem consultant, you can save this XML file and you can pass it to an email to your clients, things like that. And you can set up a shared drive within your company's network that allows people to share, workflows. So if you work for a large organization, you can access workflows from shared drives within the ioGAS menu. So the workflow recorder is quite flexible. So when you play it, it has automatic variable conversion. So for example, if I record a workflow that has titanium oxide in it, but you only have titanium analyzed as ppm, it does that automatic variable conversion, so you can run it regardless. And you can also choose to, and I mentioned this briefly at the start, but you can record ways to export out of ioGAS, and that includes exporting as a CSV file, as a gas file, but also exporting gas files from ranked variable maps, for example, and things like that. And we also support drill hole selection in the workflow recorder, which we will show in the live demo after this. So some of the likely user case, what we talked about in the past few minutes, essentially it boils down to three things. So by the use of the workflow recorder, we allow people to create standardized workflow within an organization. So that means creating consistent classification output across a project, which means that they can easily maintain best practices between teams within a company. So for example, if you receive new assay data from the lab, from a different prospect, for example, you can apply the same classification routine. And strongly tied to that is IP retention. So if you have ioGAS experts within your organization, if you want to retain that knowledge in-house, the workflow recorder is the next step beyond having a list of provided diagrams that you record in-house. So some of our clients who work for large organizations will have a library of custom diagrams. So what we imagine this to be is for companies to have a library of custom workflows that they can record. So a custom workflow can, of course, have custom diagrams, for example, that a power user within a company has compiled for others within that organization. And it can also automate some of the more routine and some might say some of the more boring things that you can do in ioGAS. So that includes cleaning up data at the start, exporting thematic files. But it can also be used as a teaching tool, which will show you an application of how this can be used in the live demo in a bit. So we will run through an example of this later on in the presentation. And this is actually a work example of how the workflow recorder can be used. So this is a paper by Steve Barnes. And it's a classification routine using trace element ratios through a classification tree. So we have two new functions in ioGAS that allows you to easily construct this. So one is select rows by query. So you can create a query now in ioGAS that if you put in a command, find thorium over titanium with values higher than 5, and then it will select the rows that satisfies this criteria. So if you imagine just going through this tree and going through each of these steps and recording it using a workflow recorder, you have essentially able to reconstruct this tree using the workflow recorder and the select rows by query. And we have done that before this webinar, but I'll show you the finished end product and how it can be used to automate this classification really, really quickly. And this is an example of the end product. So generally, there are two ways that the workflow can be played. So one is through the workflow editor. So you can run things through each step, so one step at a time, and you can choose to let it run from start to finish, or from anywhere in here all the way to the finish line if you wish to do so. And then we also have the workflow player, which will, it runs from start to finish with no interruption. And we'll run through an example of how you can use both. And so this is the end product, right? So it takes less than 5 seconds to run this on a 5,000 row data set, just running this on a barcode project data set. And we'll show how this is run in a bit. Another type of workflow that we support is called the import workflows. So the import workflow is basically a way of automating steps in importing a new file into ioGAS. So if you are used to bringing in assay data from the lab, for example, and if you do the same thing every time, and that includes, removing columns you don't need, renaming the columns to a typical way that you would name it. And if you do the same thing every time, you can record those steps using an import workflow. And that will just speed up your workflow by quite a fair bit, just by making that process at the start a bit quicker and easier to do. And so the workflow recorder is meant to be used in conjunction with this new feature called file reload. So it's a new button on the file ribbon. So if you've used ioGAS for the past few releases, you will know that we have the file append and the file join function. So this sort of works similarly to that, but it has more flexibility in that if you modify a file that you used to bring into your workspace, if you modify the source file with new rows or new columns, it will refresh the data with updated version of the original source file. So it's really useful, for example, if you receive new assay data, and if your database person spits that out as a master CSV file, and if your master CSV file gets updated, you can just click on the reload button, and it will try to keep most of the open plot windows that you have in ioGAS. And for some reason, if the plots that you have are not being restored, then you can use this in conjunction with the workflow recorder to record the plots that are not being restored using the file reload. And we'll show a demo of this as well. So undo and redo is something that people have been asking for a long time. I know myself, I have been asking for this for a while because I've used ioGAS for almost 12 years now, 12, 13 years. But this is one of those things that will make people, it will save quite a bit of time, especially if you make a mistake when you're attributing a polygon. So you can undo that sort of thing. And it will restore ioGAS to a previous state, so you can undo and you can redo as well. So this is one of those things that will be better once I show it live in action. We have this new feature called tool search, and it is exactly what it is. So if you ever struggle to find certain diagrams or tools in ioGAS, you can easily do this to find the diagram that you were looking for. So you can access it from the quick access toolbar in the top right. And then it will also allow you to, you can right mouse click on the search result to find the item on the GUI. So we find it to be quite handy, especially when finding spider plots and diagrams and calculations and even certain tools that we're just not sure where of. So it's quite useful. And we have enhanced the attribute manager as well. So this is, so the attribute manager, it hasn't been really changed since we added the filter tab, which was back before version 7. So the filter tab was the last big thing that we've added to the attribute manager. But now we have added a couple of new things in here. So we are now able to sort attributes by color. So it does it by color shade, which is quite useful actually, especially if you have hundreds of colors in your data, hundreds of color groups. And you can also invert visibility. So if you set some groups, a couple of groups to invisible, you can switch that around. And you can also right click on an item in the select variables, in the attribute manager group. And then you can pinpoint points and plots from that selected attribute group. So this is a new dimension reduction technique. So it lives under the analysis ribbon. It's called Umap. So it stands for Uniform Manifold Approximation and Projection. It works much like the TSNE, but it has some advantages over it, such as its speed and the fact that you can actually reproject data into a safe UMAP. So it's an unsupervised dimension reduction technique, and you can cluster the results manually using your own eyes, or you can cluster it using Kmeans and dbScan. So it does work quite well, and we'll show an example on how we can run this using the barcode dataset in a bit. Right, so on the plot tools, a couple of things that will be quite useful to know. We can now open multiple grid windows. So previously, there's an architectural limitation, well, more processing limitation that means that we can only open one grid window, but now we can open multiple grid windows, so that will be quite handy. We have a new simple render mode. So if you have millions of data points, well, hundreds of thousands to millions of data points, if you open up a scatter plot, this simple render mode can speed up redraw of a large number of data points in certain plot windows. So for example, if you open a scatter plot matrix, if you have hundreds of thousands of data points, this should speed things up by quite a bit. So how it does it is it only displays color attributes rather than shape and size and shape outlines and things like that. And so this is what I was talking about earlier. So that's a select rows by query tool. So it's a new tool that's found in the data view, but you can also access it from anywhere else in GAS. But it allows you to select and highlight a subset of the data based on a certain criteria. So over on the screen here on my screenshot, you can see I want to find rows that correspond to regolith units called DA, and also has copper higher than 50 ppm. And so you can use this expression builder to build your query, but you can also type it in yourself if you know the syntax. Might be faster if you type it in yourself, if you know the syntax. But if you don't, you can use the expression builder, and it's actually quite quick to do it this way as well. So we'll show you an example of how this can be done. But the select rows by query tool, so this query, so this syntax here, you can actually save this, right? So you can save the query expression as an XML file that you can pass to others within your company, and you can reopen it and use it in another data set, for example. And you can also record this within a workflow. So that's Steve Barnes' workflow that I showed you earlier with that classification tree. So that was constructed mostly using the select rows by query tool, and just by automating these steps within within a workflow. And one other thing to keep in mind is that it has missing analysis built in. So for example, if I make a query that looks for copper less than 50 ppm, and if it turns out that over half of my data doesn't actually have copper analyzed, it will spit out a missing analysis tool that will let me know that your results are only valid for this many rows, and that's because 50% of your data wasn't actually analyzed for copper. So things like that. So makes the result more robust and useful to understand. So another thing that people have been asking for a while is the ability to highlight cell in a crosstab. So when you're seeing a crosstab of two columns, so two text columns, and using it in a crosstab in ioGAS, if you press your left mouse click on any cell here, it will highlight the rows that correspond to that corresponds to this criteria. So for example, if I click my left mouse button on the intersection between DC and AG, between these two columns, between these two values, it will highlight the rows that satisfy the criteria. And we have reworked the find and replace tool. So if you have used this in the past, we just now made it a bit more modern, a bit nicer to look at, and easier to use. And if you have previously exported output from ioGAS as text columns, and if you export it out of ioGAS into Excel to concatenate, well, you don't need to do that anymore, because now you can concatenate between two text columns in ioGAS, and you can choose the concatenating character as well. So this is quite useful for merging two different text columns together. So that search tool that I mentioned earlier, we have that functionality in the mineral and rock node tab as well. So if you ever struggle to find certain rock nodes or certain OSNACA or ORIA standards, you can type it in the search bar here, and it will guide you to the right tab to be selected. So I'll show a demo of this. Right, so we've added some new mineral nodes as well. The list is quite plentiful, but feel free to take a look at it in the help file for the complete list. But one thing to highlight is we've added a number of new lithium and cobalt minerals used in production of EV batteries. We've also added a provided battery element selection, and we can also now sort variables alphabetically on the right-hand side and on the left side as well, so that's quite useful. Added a couple of new provided resource and provided diagrams, and the full list you can, of course, see in our help file as well. And we have finally added a live link with ArcGIS Pro, but it's only compatible really with ArcGIS Pro 3.0 and ioGAS version 8 and later. So it's a live link that functions similar to the QGIS live link, but it allows you to see data attributed in ioGAS and displayed in ArcGIS Pro. And it also goes the other way. So if you have data in ArcGIS Pro, you can visualize it in ioGAS. And if you select data points that plots within a polygon, within a geology map polygon, for example, in ArcGIS Pro, you can select that and have that be attributed in the ioGAS side instantaneously. So it works quite similarly to the ArcGIS, with the QGIS live link. Right, a number of new features, improvement, and fixes. One thing I like to highlight is if you are a frequent user of our PCA Blackplot, we can now lock biplot vectors when we change visibility of attribute groups. So that's quite useful. So if you just want to know where certain groups are, if you have many groups in a PCA biplot, you turn a group on and off, it doesn't redraw the arrow direction. So just keeps that in place, which is quite useful when you just want to assess where certain groups are located within your PCA biplot. Right, let's jump onto the demo. I'll bring up ioGAS version 8 here. So we'll just start off with opening the barcode dataset. So it's already open. I'll just show you quickly the attribute map of this data. Now we'll start off with a simple data doctor. So we haven't changed anything in the data doctor per se, but we can now, when we record a workflow, we can actually automate the process of this replacement in the data doctor through the workflow recorder. But at the moment, we don't actually have the workflow recorder active yet, but we'll show that in the next data set that we'll open in this demo. So now what we're going to do is we're going to go to the select variables dialog, and I'll show you how we can right-click on this field here under the available list. And you can see as I press my right-click, it sorts things alphabetically. And you can also sort it on the right-hand side as well. So the right mouse button cycles between group alphabetic order, and the user selection order. So if you look under provided groups, you can also now see that we have the battery list of elements here. So lithium, nickel, cobalt, manganese, and so on and so forth. All right, so let's open some immobile elements. And let's open up a scatterplot matrix just to see the distribution for data. Looking good. And now what we want to do is we want to use the tool search. So the tool search can be found on the upper right-hand corner. So in the search bar, so we can now search for anything here, basically. So say if I want to open a Winchester and Floyd diagram, I mean, I know where it is. It's in the diagram trace elements, but if I don't know where it is, and if I just want to open it, I can just type it in, and it'll guide me to where it is. And you can just click on it to open it automatically. And say if I want to open the Whitehead and Davis alteration diagram, I can do that as well. And it can also work for, so not just diagrams, but it can also work for spider plot. So say if I want to look for the Aurea 72B spider plot, I can do that as well. And it also works for tools. So if I want to search for maybe biplot, it will take me to the appropriate menu option. So I'm going to open a biplot and just leave this here. So now I'm going to auto attribute this diagram, and I'm just going to create a new column. And now I'm going to go to the mineral and rock nodes dialog. And now you see that we have a bunch of, we have this search bar here. So I'm just going to remove all of my selected minerals and rocks. And so if I want to find a rock node for basalt, for example, I can just type that in, and it will highlight the tabs that has the word basalt in it. So some of the Aureus standards will have them. So with the blanks, of course, and with the nickel standard as well, but also, of course, with the USGS standard and the Cox et al. So look, so I'm just gonna select a couple of these from this list, and we'll see where they plot in that volcanic rock classification diagram. And it also works for minerals as well. So if I want to select, say for example, aldite, it takes me to the right supergroup, which is minerals. If I want to find something like fangite, for example, take me to schist silicates. So it's quite handy, especially if you're not sure which tab your mineral would fall under. It also works across the minerals, OSNACA, rocks, and the user tab. So it works across all grounds. So if I can just plot up those nodes, you can see where it plots here. You might not be able to see it that well because of the colors, but it's a really faster way of just bringing up your nodes to display and finding them, which can take a while if you're not sure where you're looking. So now what we're going to plot next is I'm going to show you how this simple render works. I'm just going to minimize all of my windows, and I'm going to open a bunch of major elements in Splunk. So if you have used ioGAS before with a large number of data points like this, you would know that the rendering can take a while, and then you might have to wait until it finished rendering. But what you might want to do now actually is we can use the simple render mode, which will make this just a bit faster. So you can access it from the right-hand side toolbar under rendering settings, and just click on this button that says simple render mode. So it only has colors enabled, and it makes the points simpler and faster to render. So you can use it for this type of workflow. So if I turn on point density, and if I create a couple of groups, then I can start attributing groups like this. And if I use that to select my last group, so it looks like I made a mistake just now. So if I can just bring this to the forefront, you can see that I wasn't meant to put that blue group there. I think I was supposed to draw it just in this cluster right here. So, well, lucky now that we have an undo function, because what I can do is I can undo what I did just now, and I can reset that blue group and actually do it right this time. So what I'll do is I can just replay that and do it right this time. So I'll just show you quickly again how that works. So if I go, all right, so that's obviously a mistake. So I didn't meant to put that purple group there, so I can just press undo. And then what I'll do is select that group again and do it right this time. So when I undo and redo, so if I click on this button here, you'll see that it has a list of every well most actions that you can do in ioGAS, but most of it includes all the things you can do in Attribute Manager. So you can go all the way up to that first step of creating the first color group. So basically, let's start again from scratch. So we don't have any color group selected at all. And if I click on the redo button, you can see a whole bunch here that you can redo. If we choose that, okay. So looks like we are happy with this interpretation after all. So that's how undo and redo works, and it should make that process a bit friendlier. But so what I'm going to do now is I'll just show you quickly while I have this. is we have this new function that lets you invert visibility. We just turn off my point density cloud. If I just disable the simple render mode, just so we can show it clearly, there's this button here that's called invert visibility. And if I click on that, you can see how it quickly just flickers through between the two groups that I have on and switch that with the group that I have switched off. So it's a quick way to switch back and forth between groups that are visible and invisible. And another thing that we have added in the attribute manager is the ability to select on a group and right click to click on show selected. And it will highlight the groups of interest just using the select tool on the plot here. So I'll just show you what that looks like, just a bit clearer. So if I look at this, if I want to see where color 04 is, just click on it and have that thing highlighted. So it's useful if you have something like this in this data set. So the preferred chemical classification column has a large number of groups in it. So, and you can sort of see how this can become useful. So if you have a large number of groups like this, so for example, if I want to see where my problematic data is plotting, I can just click on that, right click and click on show selected and see where they're plotting. So it's just highlighted using the select highlighter tool. And another thing that we've added, we can now sort colors by hue and luminosity. So it's actually quite handy, especially if you have, certain, color ramp that you use to characterize alteration and rock type, for example. You can now sort by color, which makes it easier to sort rocks by RGB coding, for example, which would be quite handy. But also, if you color it based on alteration grading and things like that, and it'll be quite useful to sort it in this way. So now let's move on and use the new Umap function. So the Umap function essentially works as a pretty powerful dimension reduction technique. And if I just grab a set of elements here that I know are useful in this data set. So the Umap result can be plotted in a 2D Umap display. Let's minimize this. But you can also create 3 output columns, in which case it will create a 3D Umap. So the 3D Umap can be rotated. So let me just expand this window a bit, so you can see it clearly. And what people can do is they can use automatic clustering, or they can use manual attribution, and they can just create groups like this to characterize clusters within this dimensionally reduced space. Or alternatively, they can put it in an automatic clustering algorithm like Kmeans, for example, or dbScan. Well, dbScan works better, but I'll just show Kmeans because it's simpler in this. So you can use it to automatically, find clusters within your Umap dimensional space as well, and seeing how that reflects in comparison to your data. So now what we want to do is we want to show how we can concatenate the result of this with the Winchester and Floyd classification. So if I just create a new column based on this coloring called Kmeans, and then I can merge that classification result with the Winchester and Floyd classification. And through the use of the merge columns function, I can create a new column that has a concatenated text. So I can choose the name for the destination, and I can also choose a separator. So I'm just going to use a hyphen. So if we look at the end result and see what that looks like. So this is the end result. So I'm basically concatenating the cluster result with the result from the Winchester and Floyd classification using the concatenate tool. So we'll run through a couple of things before we finish off and before we move on to the workflow recorder. So what I want to show you now is we can easily create multiple map grid window. So for example, I can open a map grid like this, just using 2 elements, and then I can select a couple of different elements here and just open another instance of the map grid, which you couldn't really do before. So that's quite neat. And another thing that I want to show you is the select rows by query, but we will show you this in a bit more detail, actually, as we run through the workflow recorder function. So the expression builder is quite easy to use. So you can access it from the right-hand side toolbar of the data view. And under column here, for example, if I want to find a lithology that corresponds to, so using the equal sign, so you have a bunch of operators to choose from. And again, the help file is a useful resource to find out more info about this. If you want to find lithology that corresponds to rocks that were locked as Kmeanite, I can select them here, so add them to this expression. And then I want to find a filter, for tungsten lower than a certain value. So for example, if I click on the drop-down list here, it gives me a choice of things that I can put in. So either the minimum, mean, median, maximum, percentile, and so on and so forth. So just for this, maybe let's say I want to put in less than the 50th percentile, which is 0.5 ppm. So let's add that to this criteria. And as I click on apply, you will see that what it does is it brings up the missing data for this query. And what that means is because I don't have assay data for 2 rows within this lithological group that corresponds to Kmeanite. And that's because I just don't have assay data for tungsten for a couple of these rows. So building the missing data query on top of the select rows function allows you to create a better result as you build your expression to find the rows of interest. So, and the thing that you can do with this is you can save this query as an XML file. So if I just save this as a query, and I'll just show you quickly what that looks like. So it just looks like an XML file. So being an XML file like this, you can share this with others within your company. And you can use this to on another data set if you wish to do so. Right, so let's move on to the workflow recorder itself. So if I just bring up this file, and again, this may be one thing that people don't know how to do, but if you drag and drop a file into the main ioGAS window, this opens it automatically. So it's a nice little trick. We've had that. We had that for a while now. Right, so I'm going to bring this file into ioGAS, and we will show how the workflow recorder works. So it at this moment, it does record most things that you can do in ioGAS, and you can access it from the workflow ribbon here. So to start the workflow recorder, just click on the new workflow button, and it will tell you to clear, it will clear all attributes and close all windows, basically to put the file into an empty state before you proceed to creating a workflow. And it will prompt you to save a checkpoint before proceeding if you wish to do so. So in this next part of the dialog, it will prompt you for the variables that you wish to open in this workflow. So you can choose as many variables that you think you will use for the workflow, but it can pick up on columns that you use throughout the workflow. So if, for example, you only select silica, titanium, aluminum, for your workflow, but as it turns out, you need iron and magnesium and manganese as you proceed, ioGAS will automatically, add those on as you're recording the workflow. But for now, let's just select all of the alias elements in this file. So the file that we're opening is the MSDP file, and it's based from our Lab at Rick project. So it's a series of 4 drill holes in this data set, at least. So 4 drill holes with some XRF data. But what we're trying to show now is we're trying to use the workflow recorder on a subset of that MSDB file. So we're creating a workflow on a subset that consists of 2 drill holes, and then we're going to reload the file. So we're going to make the file bigger and then rerun that workflow on a larger data set. So the next step that we'll do, and this is the first thing that I do every time, is to open up the data doctor. So this data doesn't actually have any issues with it, but this is just something that I like to do every time I record a workflow. So when we record the action of recording that data doctor in a workflow recorder, you can choose for it to record individual replacements. So what that means is if you always replace silver ppm, if you assign a below detection limit replacement of of 0.005, every time you bring in for this particular project, for example, you can choose to record individual replacement. But you can also simulate the action of clicking on replace all and just use with what ioGAS recommends, which is lowest half positive. So clicking on record replace all operation is sort of a way to let ioGAS know to just let it replace based on the suggested replacement value. And that's quite handy in itself by automating that data doctor process. So we're now going to open a probability plot. And now I'm going to open a histogram. I'm going to tile my windows. And then I'm going to actually now stop the workflow. And I'm going to add a manual step here. So this manual step, it's basically a prompt for the person who's going to be playing this workflow in the future to do anything, right? So in this step, I would go assess distribution of all essay elements using prop plot and histogram. And this is the message that will appear when I play this workflow in the future. And it's what we call that guiding part of a guided workflow. So let's resume the recorder, and now let's open a couple of diagrams. So I'm going to open a Halberg classification diagram. I'm going to auto attribute based on my date plot here. Oh, oops, I've actually forgot to auto attribute. I'm going to create a class here called Halberg. And then I'm going to open another diagram. And then I'm going to record the creation of a drill hole using a zirconium over titanium column. So that's what's used in the y-axis in the Spears 1996 diagram. And I'm going to open a downhole plot just for that element. And when I record the action of creating a drill hole, when playing back a workflow that contains a recorded drill hole, I can choose for it to use the recorded drill holes. And now what that means is that it will look for drill holes of the exact same name in that new file or in the file that I'm running the workflow on. So it's going to look for MSDP01, MSDP02. But if I click on use all drill holes, it sort of simulates clicking on this checkbox. And the third option here, select on playback, is it will stop at this step and allow you to select the holes that you want to plot. But if you want to choose to create a workflow that can run from start to finish with minimal interruption and runs on the new data set with minimal interruption, you will want to use the use all drill holes option. So now what we want to do is we want to create a Umap. So what we're going to show you now is we can record things like biplot and TSNE, but also things like the Umap in a workflow. So what we're going to do now is we're going to just open a simple 2D Umap, and we're going to assign Kmeans clustering on this Umap plot, and we're going to save the coloring in this as a new as a new column in the file. So one thing that I didn't mention is that you can reuse a Umap. So you can save a Umap through the through an XML file. So there's a button on the right-hand side toolbar that allows you to save Umap embedding to XML file. So if you've ever reproject a data to a discriminant projection space using discriminant projection analysis in ioGAS, or if you have reprojected data onto a principal component analysis space, this sort of works similarly. So you can project new data into the lower dimensional embedding space created by the Umap algorithm. And of course, you can save this as an XML file that you can share around with others within your company as well to use on a new project, for example, with similar rocks. So now we're going to record the action of exporting the output as a text file. So just a couple of text files. And I've selected those columns. And what I'm going to do now is going to select these two variables and export the selected columns for all rows. And I choose to export just those two columns into the Excel spreadsheet file, into an Excel spreadsheet file. And when I play back this workflow, I will have the option of overwriting the original output file or browse to the location where that output file is generated every time the workflow is run. Or I can choose to export to the user exports directory. So the user exports directory is a new concept in ioGAS 8. And basically, when you export anything new out of ioGAS, it will export it to that folder. And you can choose to configure that folder. And if you run it like this, and I'll show you how it's run in the next example, it will create a unique suffix folder that has all of your output every time you run a workflow, for example. So we'll just keep it simple this time. We'll just export that selected columns to an output Excel spreadsheet file. So the last thing that we do before we stop this workflow creation is to plot a crosstab. So I'm going to plot a crosstab of the log lithology versus the interpreted classification using the Umap and Kmeans classification. So as you can see here, there's a message that says add source columns litho1 name to required columns for workflow. And that's because if you remember at the start, I only selected assay columns as a required column for this workflow. And because I didn't select litho1 name, and now I'm using litho1, this column as an output, or what I'm using in this workflow, the workflow recorder is asking me if I want to add this as a new required column for this workflow. So I'll just say yes. So that principle also applies for, if you decide to add more assay columns to your workflow, it will ask you if you want to add it to the workflow recorder. So now what we want to do is we want to open a Crosstab and then go to Attribute Manager. And I'm going to auto attribute just based on the log lithology. And I'll show you why we want to do that. So now what we're going to do is we just want to make sure that we stop this workflow. Now we're going to save this as an XML file. And let me just show you quickly what that XML file looks like. So the syntax is quite straightforward to use. And basically, it records the actions within the workflow. So you can pass around this XML. If you record a workflow, you can pass this, the XML file to others within your company. So it's just it's a small XML file that allows you to apply the same workflow basically in another data set. So now what I want to show you is how the reload function works. So if I just catch your attention to this file size, so this is the file that we use in this workflow, MSDP1 and 2. So it's only 400 kilobyte, and it only has 2 drill holes. And I'm going to, basically simulate updating that file with new assay data from the lab. I'm just going to replace this file. And then I'm going to click on the reload button in the file ribbon. And so some derived columns, some derived columns in ioGAS may not be restored when you reload, but this is why we encourage people to use the workflow recorder in conjunction with the file reload function. So as you can see here, so if I just bring up the legend, you can see that there's a new color group here called new reloaded data. So it's just the one in this bottom here. So it's with the color gray here. So you can sort of see that it has reloaded, it has added new rows into the file, and it's adding it as a new color group, which you can see in this classification diagram. You can see it in the histogram, in the distribution here. You can also see it in this probability plot right here as well. But the point of this is we can continue working with the data with minimal interruption just by keep on reloading and adding new rows into the data. And using this in conjunction with the workflow recorder allows you to continue working the way that you did before and generate outputs automatically as you proceed with the interpretation. So now we're going to actually run that workflow that we record. I'm going to show you a couple of ways that you can do this using the workflow player. So that's one way that we can do it using the workflow player, which if you notice, it's almost the same interface as the workflow editor. So in this way of opening a workflow, you can choose to run through each step one at a time. So it goes through it step by step. And if it reaches a user input operation, it will ask you to pause and do what it asks you to do. So if I'm creating this workflow for others, for example, I can say, assess distribution of all assay elements, blah blah blah, and then once you're done with that, so let's pretend that we've done that step. So let's just continue in that workflow, and then we can carry on. So it does going it through one at a time. It's quite useful if you want to methodically go through each step in sequence and seeing exactly how that person recorded that workflow in the first place. But you can also play straight to the end. So this is what we call just let it rip all the way to the very end. It runs through everything. So if you notice here, this file is bigger than the previous file, and it has 4 drill holes as opposed to 2. So it's the equivalent of receiving your assay data from the lab. So instead of 2 drill holes, now we have 4. And the reason why I choose to auto attribute by the log lithology is so now we can compare the result of the log lithology versus the automatic clustering that we have done using the Kmeans algorithm on that Umap plot. So if I click on my left mouse button in this crosstab, in the cluster 1 and Rayleigh classification and the Rayleigh to cluster 1 cell, you can see how as I click on the cell, it highlights the part of the Ross log as Rayleigh near the bottom of the hole that corresponds to cluster 1. If I click on the one that corresponds to cluster 3, you can see how it corresponds to a different part of the hole, and that's because they're chemically different and they happen to be plotting in different parts of the hole. And so you can see how this workflow can be quite useful using a combination of the crosstab and the Umap and the downhole plot, and seeing how that correlates to different, probably different subgroups within an existing log lithology group, just as an example. But the point of running the reload and the workflow recorder and replaying the workflow on the reloaded data at the same time means that you can automate and make that process, much, much faster. So that is the workflow recorder using the MSDP data. And I will now show you the example that we showed earlier. So the example that we done from this paper. So from this case study, what we've done is basically we've created a bunch of select rows by query through each of these steps. And we've basically allocated rows that corresponds to certain criteria into lithology group. So if I just open up the barcode data again, So this is the first data set that we look at. And if I can show you that workflow that we used to show, actually it's here. Yeah, so if you look through each step, so for example, in this step, select where thorium titanium is higher than 5. And then if you see further down the list here, you can see there's actually a whole bunch of select where. So all of these type of criteria, those are what's generated from the data ribbon, from this dialog here. So those were constructed using this tool, right? So what we've done is we've managed to record a whole bunch of these into steps, and we will use this to automatically create groups. So what I'll do now is I will play this all the way to the end. You can see how it's done a pretty good job of doing it quite fast. And this is using the barcode data set. And you can see how it's allocated data into groups that correspond to the classification that has been worked out here based on the criteria that has been set out in that paper. So people, we imagine that this is one of those things that people would have in the industry. So they have their own in-house way of classifying their data. And using the workflow recorder with the select rows by query allows them to record, or at least make the process consistent and repeatable across different data sets using the combination of the workflow recorder and select rows by query. But what I want to show you actually is a step at the very end. So we can actually record a step in the workflow. We can record a step in between steps in the workflow, but we're not going to show you that during this webinar. But if you're interested, always feel free to reach out to us for a demo, or you can take a look at our help file. But you can add a step in between steps. But what I'm going to show you is we can add a step at the end of this recorded workflow. And the step that I'm going to do is actually quite straightforward. So I'm going to open a variable map. And I'm going to export this as a gas file. So I'm going to export the output of this ranked variable map. So each one as a separate gas file that I can import into a GIS program, so ArcGIS or QGIS. And the reason why I selected these elements because these are the ratios that were proven to be quite useful in distinguishing between the rocks in this study area. So I just created a gas file export based on each of these variable map. But instead of this first option here to overwrite the original output, I'm going to export to a user exports directory. So before we do that, I'm just going to pay your attention to this new folder that we have. So it's called ioGAS exports. So at the moment here it's empty except for one folder. But if I click on this button, it wouldn't do it. But the next time I run this workflow, it will populate that folder with output columns. So what I'll do now is I'm going to save this. I'm going to save this as a new workflow. And now what we're going to do is we're going to close the file, reopen it, and rerun that workflow. And I'll show you the other way that you can run a workflow, and that is our favorite way of running it. So that's this is the let it rip option. So it goes from start to finish with no interruption, and it even does the automatic batch export of the output gas files automatically. So you can use that. You can use that to generate. So you see that column here. So that was generated at 6:02, so about less than a minute ago, and it outputs the appropriate gas files from each of the ranked variable map. But if I just open up this one, just to show the resulting output, it kind of looks like this. So this is just the variable map that was exported from that previous from the previous export result. So that is what we're showing through a work example of this automated workflow as a case study, and that pretty much sums up the ioGAS V8 webinar. So just before we wrap up, just letting you know that we do have, if anyone's interested, we do have some online and in-person training scheduled for next year. So we got a number of online training over 3 days, so about 2 to 3 hours each day in January next year, but also over in the North America time zone, which probably does not apply to those of you who are listening in to this call. But we do have quite a few here, and if you're interested, feel free to reach out to me or to the ioGAS@indexlimited.com email for more info. And yeah, as we speak now, we should be able to. You should be able to access the installer in this page.
Yes, Putra. All good.
Yep.
It's all done. It's
all done.
there.
Okay, it's there.
Yep.
Right. So let me just put up the screen again, and yeah. So there you go.
We'll
Thanks.
copy that link into the chat so people can find it.
Yep.
Great job, Putra.
Thanks.
As I said,
Thanks, Dave.
chat, not many people do live new release software demos, but
Yeah.
but Putra still does, and it's fantastic because it makes it real.
No, it's nerve-wracking, but it'll when it works, right? So.
Of course it works, Putra. Come on. Hey, so thanks a lot, everyone. The link's there. You can go and get it, and of course we look forward to feedback. We're quite aware that with the workflow manager, people will put it to uses that we've never ever dreamt of. So if you do something really quite weird and bizarre that's useful, please let us know. Send us a picture or something.
Awesome. Thanks, everyone. And we're pretty keen to hear how you guys are using the new features, including file reload and the workflow recorder. So yeah, let us know how it goes. And of course, the recording for this webinar will be made available to you guys, and we'll shortly make this recording available to everyone else as well. So if you want to pass it on to others within your organization.
Good job.
Thanks, everyone.
There it is. I just popped it in.
Yes, thank you.
Thanks, everyone. Have a good morning, evening, afternoon, wherever you are.
Thank you.